Hello again. I'm going to try to cover the homework from Miller Chapter 4 in a few videos. I have my whiteboard set up to cover numbers 4 and 5 in this video um, while some kids play right behind me outside. So we'll see how well this goes. Here we go. Number 4. There are simultaneous changes in the demand for and supply of tablet devices, with the consequences being an unambiguous decrease in the equilibrium quantity of these devices, but no change in the market clearing price. What changes in the demand for and supply of tablet devices could have generated these outcomes? So we're talking about tablets, and I have set up the market model just without any changes. Now, the prompt says that this is going to remain constant. Price will stay where it is. There's going to be a shift in supply and demand, yet the price is going to come out to be the same. But quantity is going to unambiguously, means without any doubt, quantity is going to fall. So let's see. Let's just dabble around a little bit with some rulers. As I can look, this is very highly, I'm sure with this, I could be doing something on PowerPoint or something like that and recording a video like that. But I don't know, let's just make it low tech. Low tech, low cost. There's my demand curve, right? If demand falls, quantity falls, right? See where it's intersecting supply? Quantity is falling as demand falls. But what's happening to price as demand falls? Price is also falling. What if demand rises? Both price and quantity rise. Now, if I held constant demand and shift supply, let's have the supply fall. This is a fall in supply because it's moving left. See, that's a fall in supply. It's moving left. As supply falls, price rises and quantity falls. But what if supply rises? This is an increase in supply. If you trace back where these things intersect, my line that you can see from your angle and the line drawn on the board that is demand, where they intersect, price is falling and quantity is rising when supply rises. So both things, when they fell, each thing, quantity falls. So we know we're talking about things falling. Supply and demand are both falling, because when demand falls and supply falls, what does it do to price? Remember, when supply fell, price rose. When demand fell, price fell. When they both fall, those two effects are offsetting. So now that I've hopefully shown that with my marker, let me go ahead and show it with, with my ruler. Let me go ahead and show it with a marker. If I shift my demand curve down, and I shift my supply curve down. Again, it's very important to know up and down in supply because it's confusing. And if you're looking at that saying that's an increase in supply, you're falling for that Jedi mind trick I warned you of in our earlier discussions around Chapter 3. This yields that outcome that we're looking for. See, the new purple equilibrium price is right here. It could be unchanged. But what's happened to the quantity? For sure, the quantity has fallen with this simultaneous shift. Any other shift, and either the price will rise or fall, or if they were to both rise, the quantity would have to rise. So the only way we could get this outcome is that if both demand falls and supply falls, and we could achieve this outcome. So that's number 4, and hopefully a decent enough explanation to get you there. Should MyLab throw you a question that is, suppose quantity fell, or quantity remained constant, but price rose, or any combination that might throw at you, you just have to think it through with these things shifting, dabble with them, and you can get to the right outcome. So that's number 4. Then number 5, you might have noticed I have a model set up here, and on your written paper, maybe you didn't do a model because it wasn't in the directions to do this as a model. But I do find it worthwhile to go ahead and plot these pairs, it helps us to see the price control the same way we're used to seeing it, which will help us in the next piece I'm going to record for number 6 as well. I also find it useful to go ahead and a couple times a semester plot the ordered pairs from a supply and demand schedule. I don't like to do that all the time. Some textbooks, I've had to use textbooks where every question pretty much required us to plot the ordered pairs. And I tell you, the thing that's even more boring than plotting ordered pairs is watching a teacher plot ordered pairs on a board. And that's what it takes to do that. And that's why I try to avoid having this tables and the numerically designated axes, because it really slows us down in a not a very productive way, I think. So I do it sometimes because we all learn differently, and some people will benefit from seeing this a couple times. So I'm not going to totally not do it. I'm just only going to do it a couple times. And of course, if you feel like that really helps you, here you go. And if you're just not getting it enough, then just let me know. So here we go with number 5. The following table depicts the quantity demanded and the quantity supplied of studio apartments in a small college town. And there are 6 rows there, 5 rows of data. What are the market price and equilibrium quantity of apartments in this town? And then he's going to impose a rent control. Okay, now to see the equilibrium price and quantity, we don't really need to graph it. We can look at that table. The equilibrium price and quantity, what that means is that is the one price where the quantity supplied is equal to the quantity demanded. And I can look at that table and I can see that at $700, the quantity demanded and the quantity supplied are equal. Okay, so we could answer that question without making this graph. We could even answer the rent control question without making this graph. But honestly, I think it's a whole lot easier to answer the rent control question with the graph in front of us. So I've tried to set this up to be able to plot these ordered pairs as quickly as possible. I put these little squigglies down here because we're skipping all the way to 0 on our axes without making the scale crazy. So here we go. The prices that we're talking about start at 600 and go up by 50s. I could put an 850 there. I don't need it, but I'm not going to use that. But I had the mark. The quantities, the entire range of the quantities, the lowest value, I might have messed up here. I thought these were symmetrically matched, but I don't think they are. Let's see if I can pull this off. I can make this work. Let's say this is 1,000, 2,000, 3,000. And so this would be 1,500, and this would be 2,500. Those aren't exactly the values listed there. I think some of these will have to fall between these. I'm quite sure of it. But I saw that in the video. But that's okay. I think you'll see what I mean in just a second. So if I fill in this model with the data given in the schedule, at $600, the quantity demanded is 3,000 units. $600, quantity demanded is 3,000 units. At $600, the quantity supplied is only 1,600 units. Well, that would be just to the right of 1,500, right? So at 6,000, 1,600 would be right about there. And then if the price were $650, the quantity demanded would fall to 2,500. So 650 is, thinking about those dotted lines I like to do, all I'm saying is this whole row across here is 650. And at 650, again, the quantity demanded is 2,500. That is right there. right there. So I'm not going to keep those dotted lines on there, but that's what, if people, sometimes I think people see the dotted lines and they think they're part of the structural part of the model. They're not, they're just guidelines for where these things line up. At 650, the quantity supplied, of course, rises and it goes to 1800, which would be somewhere just left of 2000. So somewhere up here, like that. And we know at 700, they are equal at 2000. 700, they are equal at 2000. I'm going to have to fudge this just a little bit. Let me move this over just a little bit left so I can make these straighter. Okay. At 750, the quantity demanded is 1500. Right about there. And at 750, the quantity supplied is 2200. Well, 2200 would be just left of halfway across 2000 and 2500, so you're right about there. And then at 800, the quantity demanded is 1000. Right about there. And the quantity supplied is 2400. Right about there. So now connecting these quantities supplied that we were given, there's our supply curve, connecting these quantities demanded that we were given, there is our demand curve. So that's plotting ordered pairs, and I think by now you can see why I don't do it very often. That's supposed to be a little bit funny. Better laugh while you can. I don't have a whole lot of funny. But now a rent control is going to be imposed. Imposes a rent control of $650 per month. How many studio apartments will be rented? Let's see, 650 is right there. So I'll make it, I'll shift to a different color marker so I can make it stand out a little bit. Okay, now a rent control, the purpose of the rent control is to keep the rent, the idea is that the current rent is too high. And sure enough, I just kept my marker, but I didn't do this. But sure enough, the equilibrium that we saw in the table and can see again here is $700 is the equilibrium price. 2,000 apartments are rented. It's deemed 700 is just deemed too high. It's too expensive. People need a place to live. Arguments like this, right? So they imposed a rent control below that. This is a price ceiling. It's a legal maximum the rent can be. And it would be binding because it is below the equilibrium price. So this is a price ceiling, and it's a binding price ceiling. It's right where it should be for it to matter. And now, just as we've done, we can see our quantity supplied and our quantity demanded. At 650, the quantity demanded is way out here at 2,500. And at 650, the quantity supplied, I'm looking at the table to make sure these line up, 1,800. That's what this was when I plotted that dot, and this was at 2,500. So the question is this, one question is this, just to make sure you're getting it, is this a surplus or a shortage? Think about that. Is this a surplus or a shortage? People want this much, but only this much is being made or provided. By the way, with apartments, that's very plausible. Starting next month, I'm going to be a landlord. I don't have to be. If I can't get good rent, I wouldn't be doing it. So I don't have to be providing apartments. I've rented rooms here in our house before we had kids. I've rented the guest bedroom out, just, people I know kind of thing. And, if I'm told by the government I can only charge a little bit of rent, that or be participating in a black market and illegal, I wouldn't do that. Well, I just might not provide it. So the supply curve is very real. Apartments don't have to be made or provided. Okay, so let's see what's going to be supplied at this lower rent. 1,800. 2,500 is wanted, 1,800 is what's supplied. How big is the shortage? 700. That's 2,500 minus 1,800. 700 units is the size of the shortage. That's the number of apartments that are wanted, but just aren't there. Let me take a quick glance at this question and make sure there's nothing I've missed. I didn't address it this way. I did address it, but I didn't specify. The question specifically says, how many studio apartments will be rented? 1,800. Right? Because that's what the sellers will provide to the market. 2,500 are what are desired. They're not rented. I know that was interesting. Now we'll come back and look at number 6 in the next video.